In, whenever masses are given, that really doesn't help me with finding the empirical formula, the simplest formula. Why? Because the masses uh, don't react according to grams. They react according to electrons. Things react according to electrons. To so the point is, electrons is like related more to the moles. Okay, the coefficients are the moles in the equation, and so we convert, if you are given the masses, we convert it to moles by dividing it to by the atomic mass of the relevant compound, and then we get the moles. So this is 1 is to 2. 1 mole of sulfur is reacting with 2 moles of this to give you this compound. Combining, we don't say reacting, combining. Here also you did, they are given you percentage, so we don't know the exact amount here also. But if it's 80%, that means out of 100 grams, 80 grams and 20 grams. Again, this is the simplest ratio. This is not, uh, we get 6.67 and 20, and the ratio, this is 1 is to 3. And so every one is combining with every 3 of hydrogen. Every 1 mole of carbon is combining with 3 moles of hydrogen. So this is the empirical formula. How to find how do we do this? What they do is, like, they burn magnesium, and so eight, so they can then, through the magnesium oxide, they can find how much magnesium got combined with this. So you can find the now if you want to convert this to the final formula, like in the previous question it was CH3. Now CH3 doesn't exist, because why? Because C has a carbon has a valency of 4. So it has got 4 electrons. So it can't it can't exist like this, CH3. So this is the simplest ratio. This doesn't mean this is the formula. The formula would be a multiple of this. It can't be half a carbon atom, but it could be a multiple of this. It could be C2H6. It could be C4H multiplier H12 or something like that. It can't be this. So what it is you, if you know the molecular formula, then you can find. So so the empirical formula ethane is CH3, but its molecular formula is this. How do we find that? If we know the molecular weight, if we know the relative molecular mass, that can be found by different ways. There's something called mass spectrometry, you will learn in higher class. What they do is they ionize it, a molecule, and then what they do is they put it in an electric field, and it kind of gets deflected, and the amount of deflection tells you what mass this is, each molecule. And once you know the molecular mass, then if you divide the empirical mass by that, you find a common factor. Because if CH3 is the simplest ratio, there could be 2 CH3 like that. This is 1 CH3, this is another CH3. And whatever multiple balances the electrons, that's the final formula. So that formula, that ratio between the molecular mass and the empirical mass will give you the. So supposing it says there's an empirical formula HO, but the molecular mass is 34 from mass spectrometry. What he does is he says, what's the empirical weight of this? This is 17. So there basically there's an HO, but there could be 1 HO, 2 HO, 3 HO. So you divide 34 by 17, that means 2 HOs are present. So the formula is H2O2. Did you understand?